Welcome to Intermediate Algebra, Chapter 1, Section 1. In this section, I'm going to work through some examples of solving linear equations by clearing parentheses. We're going to wrestle with some fractions. We'll get rid of some decimals, and we'll see some unusual types of equations that are always true and that are never true. And I'm just going to go through and work through some solutions, and I'll put some little annotations next to the equations so that you can maybe take some notes and be able to recall what it is that we did in order to go from one line to the next. And if you hear meowing in the background, that's because I have a 9-month-old cat outside the door of my home office here. And if she's still there by the time we're done with this lesson, I'll bring her in and introduce her to you. But first, let's look at this equation, and I'm glancing down because I've already delivered this lesson and apparently I didn't hit the record button, so I'm just looking down to make sure that it's actually recording, and it is this time. So I can safely distribute multiplication by 8 to both of the terms inside of these parentheses, distribute multiplication by -9 to the inside of those parentheses, and the little note that I like to put, DIST, tells me that I distributed in order to go from this line, where DIST is written, to the next version of this equation, which is 8b minus 16 plus 3b equals -9b plus 9. The negative times the negative there makes the positive 9 at the end. And on the left-hand side of my equation, I see 8b's and 3b's, which means I can combine like terms, CLT, which gives us 11b on the left-hand side. There's still a minus 16 on the left-hand side, and on the right-hand side we've got the -9b and the positive 9. The next thing that I'm going to do is I'm going to try to gather all of my variables onto one side of the equation. The cat's driving me nuts. Let's just bring her in now, shall we? Come here. You're insane. Get in here. Yeah, you miss me. I get it. Come say hello. Her ears are just big enough, right? She's got one bad eye because one of her sisters beat her up when she was little. Yeah, you're a good girl. Except when you're being noisy when I'm trying to make recordings. Alright, go up there for a second. Let's try to finish this problem. So I'm going to add 9b to both sides of the equation in order to get all my variables onto one side. And I'll put a little note in parentheses here that I'm adding 9b to both sides. So it's a note about what I'm doing to both sides of the equation. That gives me 20b on the left-hand side. I'm going to leave the minus 16 there still. The -9b on the right-hand side plus the 9b that we're adding cancels those out, and we only have a 9 on the right-hand side. And then I'm going to add 16 to both sides, so I'm moving my constant values away from the variable. So I have the 20b on the left-hand side equals 25 on the right-hand side. And then we can divide both sides by 20 in order to isolate the variable finally. And that'll leave us with b equaling 25 over 20, which is not our final answer because we need to simplify whenever possible. And this is going to reduce to 5 over 4. And I'll put a box around that as my final answer. In the next problem, I'm going to move over here to problem number 3, actually. I'm going to get rid of this one just so I can use the space that was available under number 2, and I'm going to work out problem number 3. So there it is. And I really hate fractions, right? So the first thing I'm going to do is I'm going to multiply the entire equation by a number into the numerator that's large enough that it'll cancel out or reduce with all of my denominators. And that number is going to have to be divisible by 2 and by 3 and by 5. And 2 times 3 is 6 times 5 is 30. So I'm going to multiply 30, multiply my entire equation by 30, and I'm actually going to write it as 30 over 1 to really illustrate that The 30 is multiplying into the numerators, and I'm not messing with the denominators at all, so you can think of that as multiplying a 1 into the denominators. All right, so let's write that out. We've got 30 times the 3x minus 7 over the original denominator, which was a 2. We've multiplied it by a 1, so it's still a 2. The next numerator also gets multiplied by 30. It was a 3x minus 5 over its original denominator of 3 equals 30 is multiplying into the next numerator. The original numerator there was 3 minus 6x. Its original denominator was 5. And now that I haven't actually done any multiplication, I just sort of put that multiple next to those existing factors, those existing numerators. Now I can reduce. 30 divided by 2 makes 15. The 30 divided by 3 will turn into a 10. And the 30 divided by 5 will turn into a 6. So we've multiplied the entire equation by 30. That was this note here. And then we've simplified. So if you want to put a little note right here that says simplify, we will be left with 15 times, Sophie, don't get on the table, just stay up there. 15 times the 3x minus 7 plus the 10 times the 3x minus 5 equals the 6 times 5 minus 6x. From here, you can distribute, combine like terms, isolate your variable, isolate the constant values, and divide by whatever's necessary, just like we did up here. We divided both sides by 20 in order to get the variable so that it was totally isolated. Our final answer on the previous problem said 1b equals something, not 20b equals something. We can continue marching through this problem pretty quickly. So let's distribute. DIST. 15 times 3 is 45x minus 15 times 7. That's 70 plus 35, which is 105. Plus 10 times 3x is 30x minus 50 equals 30 minus 36x. I'm going to regret doing this problem out. These numbers are getting unruly. Let's combine like terms. CLT. On the left-hand side, I've got 45x's and 30x's for a total of 75x's. I've got a negative 105 and a negative 50, which makes negative or minus 155. And on the right-hand side, we're not going to change anything over there. There are no terms to combine, so the 30 minus 36x. I almost went right off the screen. All right, now, again, let's move the variables first. I don't want to end up getting stuck having to subtract 75x from both sides. That's not going to be nice. I'd rather start out immediately here by adding 36x to both sides. So we could put a little note over here that says what it is that we're doing, plus 36x. 75 plus 36 is 111 x's. The minus 155 is still there, equals 30. And then we need to add 155 to both sides. I'm praying that my mental math and my arithmetic is going to work out here. So on the left-hand side, we still have the 111x. On the right-hand side, we've got 185. And that's terrible. Divide both sides by 111, and you get x equals 185 111ths. An answer like this tells me that I probably made an arithmetic mistake. Is it possible that I made that mistake because I have a cat on my shoulders? Absolutely. Did you probably see where I made the mistake a long time ago? Probably. I'm glancing back to see if I can see it just very quickly. That's 45, 70, 35, 105. That looks okay. That's a 30. That's a negative 36. Yep. Those added together. That looks good. Those subtracted together. That looks good. That plus that does indeed make positive 185. Those add together to make 111. Maybe that's just what it is. Sometimes we get not nice answers. This is a great example if this really is the right answer, which, I mean, I just checked my work. I think that's it. It's a good illustration of when sometimes fractions are much more preferable to a decimal. I don't want to know what this answer is as a decimal. It's not going to be a nice number. So, if I've made a mistake, I'll apologize in advance, but I think that's looking okay. 33x minus 7, 3... Oh, I found it. I made the mistake a long time ago. Wow. Look at this. See this 3 minus 5x right here? See this 3x minus 5 right here? Mistake. Okay, so you've got to go slowly enough. It's a little tricky articulating these things and writing and having the cat meowing all at the same time. Plus it's like 9 o'clock at night and I taught a few classes and I've been up since 5:30. So I apologize for that, but go back through, rework that problem, and see what you get as a correct answer. I'll post it and I'll put the correct answer in the notes. But so that we don't spend any more time on that problem, I hate that problem now, I'm going to look at number 4, which has decimals in it, and I don't want those decimals to be there. I would really like it if this decimal moved to the right, and this decimal moved to the right one place so that that said 2, and that said 536. We can make that happen by multiplying both sides of our equation by 10. And if we do, this does become a 2x, and this becomes minus 536. Don't forget to multiply the right-hand side by 10 also. That becomes 10x. And then we can subtract 2x from both sides in order to get all of our variables together on one side. So the left-hand side is negative 536, the right-hand side is positive 8x. And to finally isolate the variable, I'm going to divide both sides by 8. I'm going to do long division sort of in my head and out loud and writing it down sort of all at the same time. How many times does 8 go into 5? 0. How many times does 8 go into 53? 6, because 6 times 8 is 48, which is pretty close to 53. It's just a little low. And that'll be a negative 6 times, actually. The difference between 48 and 53 is 5, so I'm going to carry the 5 to the 6, which makes it a 56. How many times does 8 go into 56? The answer is 7. And so your final answer is negative 67. That went much better than the previous one. The cat will probably break something back there. We'll see. She's a climber. It's dangerous. In the next problem, I would multiply both sides by 100 in order to move that decimal point to the right 2 places. So let's do that times 100. That's going to turn that into a 4. We still have the a plus 6. This is going to turn into a 100a, and the right-hand side turns into a 50. Then I'm going to distribute 4a plus 24 plus 100a equals 50. And then we'll combine like terms on the left-hand side. So we have 104a's plus 24 equals 50. Subtract 24 from both sides, leaves us with a 26 on the right-hand side and a 104a on the left-hand side. And then you need to divide both sides by 104. Isn't that going to be a nice answer? So a is equal to 26 over 104. Put a little note in there, divided both sides by 104. Is this our final answer? No. Can it be reduced? Yes. How do I know that? Because the numerator and denominator at the very least are both even numbers, so I can divide both of them by 2. So let's see, I'm going to move over just a little bit. A equals 13 over 52. Can I reduce this any further? Only if 52 is divisible by 13. And it is. 13 times 4 is equal to 52. Yep, I doubted myself for a second there. So you've got a final answer of A equals 1/4. So we've got decimals, we've got fractions, we've got distributing, we've got learning from our mistakes, right? We have to go slowly enough and carefully enough that we don't make a mistake like this one. That was too simple of a mistake to have made. Don't do that. Let's check out a couple of word problems. In this one, we have a student in their first semester of college. The college charges $105 per credit hour, a one-time admission fee of $50. So the cost for the first semester is represented by this equation, C equals, where H represents the number of credit hours taken. The student is billed $1,415. Do you think that's a C value or an H value? Well, thankfully, we don't have to do much interpretation. We're being told here that capital C is representing the cost in dollars. So I'm going to replace this C value with the 1415. So we end up with 1415 is equal to 105H plus 50. Subtract 50 from both sides. I mean, this is pretty straightforward. There's only one variable left, so I know what I'm solving for. I'm solving for H. Let's get that variable isolated. Subtract 50 from both sides. We've got 1,385. I'm not great at arithmetic. Upper level math, yes. Subtraction in my head, not so great. Hopefully most of you are sitting there with a 4-function calculator anyway. I should have one off to the side myself. Okay. That's a 15, take away 15, and another 15, and that's only 30. I'm too tired to be doing this right now. $25, $35, $40. $35 and 15 makes 50. Nice. Okay, so that's equal to 105H. Divide both sides by 105 and you'll have your final answer. Am I really even... See, this I can do in my head because I've got 100 here. That's 100, and this is if my pen works, this is 1300s. How many times does 100 go into 1300s? 13 times, obviously. How many? So that helps me answer the question, how many times does 5 go into 65? Well, I can do that multiplication pretty quickly, or I can also look at that multiplication right here. 5 times 3 is 15. So you write down the 5, carry the 1, and then the 5 times the 1 makes 50, plus the 1 that we carried makes 60. Oh, 65. There it is. Or do the smart thing and just use a 4-function calculator so you don't have to be fiddling around with this and making mistakes that are going to be permanently recorded and put onto YouTube. 13 credit hours. All right, full-time student, right? A couple of final, more straightforward algebraic problems. Solving this equation, pretty easy, doing things that we've done already. DIST for distribute. This time I'm distributing multiplication by -2, so make sure you take that negative with you. I've got 8x minus 10 minus 8x equals -10. I'll combine like terms. The 8x's are going to cancel, the positive and the negative 8x, and I'm left with negative 10 equals negative 10. How often is that true? I'd say negative 10 is equal to negative 10 all the time. Give me an x value. How about negative 4? Does negative 10 still equal negative 10? Of course it does. How about x equals 0? Does negative 10 still equal negative 10? Sure does. What about x equals positive 1,003.79? See where I'm going with this? Negative 10 is equal to negative 10 all the time. For which x values? All of them. Some of us say all real numbers. Or using interval notation, we could express all real numbers as going from negative infinity to positive infinity. A symbol that you don't see very often is a blackboard R. This is like a capital R with a double vertical bar, and that also represents the set of all real numbers. This kind of a statement, negative 10 equaling negative 10, is called an identity. So that's this one right here. Check. Let's see what's in the next problem. Just very quickly, let's do the distribution. 30x minus 10 minus, and the cat's on the iPad. Sitting on the iPad. Come on. Help me out here. Minus 30x equals 10. Combine like terms. The negative 30x away from the positive 30x. Those are going to cancel out. Left-hand side is still negative 10. Right-hand side is positive 10. How often does negative 10 equal positive 10? How about never? For no x values. How do I represent for no x values? Maybe there's a multiple choice option or a drop down that says no solution. That would be good. Otherwise, sometimes it's represented by empty set braces that are facing each other, or you might see it written as a circle with a slash through it. Both of those represent the null set. N-U-L-L-S-E-T, null set. Okay. This statement, however, right here is referred to as a contradiction. I don't think that's very surprising. So what's a conditional equation? That's the only one that's left. This is a conditional equation. An equation that has a solution or a handful of solutions, maybe we could say a finite number of solutions. It's an equation that's only true under certain conditions. That's why they call it a conditional equation. Yep, this was a conditional equation. This original equation was true only for an a value of 1/4. And we'll get to other equations that have multiple solutions. The last problem in here, let's do it real quick. Let's distribute multiplication by 1/2 to these two terms. We'll distribute multiplication by 6 to these two terms. That gives me a 2x minus 3 equals 2x minus 3 plus 9. Subtract 2x from both sides, those will disappear. Add 3 to both sides, those will disappear. So on the left-hand side, after subtracting 2x and adding 3 to both sides, you're going to have 0 on the left-hand side. And on the right-hand side, you're going to have a positive 9. Yet another contradiction. So this equation has no solution. I'm just double-checking my arithmetic one more time because I'm sleepy, and I think we got that one. So again, empty set, null set, contradiction. That is the end of Chapter 1, Section 1. Sophie has finally settled down. She's hiding from us. Thankfully, finally, I'm just going to stay right where I'm at and knock out 1.2. See you in 1.2.